Hello, I'm Racer445 here for CG Tuts Plus, and today I'll be showing you the basics of normal mapping, and normal map baking specifically. So, first off, what's a normal map do? Well, a normal map allows you to make changes to the lighting and smoothing of the surface, and to you, what it means is that you can make a much smoother model with a very, very low poly count. So this is a model that I've cooked up, and it's pretty basic. It's about 1660 tries, and once we apply our normal map, you can notice that it looks multiple times its try count, or the actual try count. But as you can see from the wireframe applied to it, it's still the exact same model. So how do we do all this? Well, first off, let me explain to you what a normal is. A normal dictates the direction that light hits the surface. So if you'd imagine this face right here, and imagine a line sticking straight out of it, just like that. That's what a normal looks like. However, what it really does is it just dictates what direction light hits the surface at, or light hits that face at. So a normal map makes changes to those normals using a map, a texture, and here's what it looks like, or here's what one form of it looks like. Now, this is a normal map, and all these fancy colors represent changes to the normals, but using a map instead of just manual lines and whatnot sticking out of the surface. So each of these colors represents a different axis. So if we go to the channels here, red means the x-axis, which is left and right, or green here, which is probably the one you'll have to fiddle with most later, is up and down, or y-axis, and blue here is depth. And altogether it looks something like this. So, applied to the model, again, allows you to make smoother models. So, there's multiple different forms of normal maps. However, the two common ones that you'll run into, especially working with games, are tangent-based normal maps, which is this one right here. These are very good for games and such because you can easily edit them in Photoshop. This is one I have edited in Photoshop to fix some errors and whatnot, and to add extra details. And it's very easy to manipulate, very easy to edit, very easy to fix. And it's the most common that you'll find in games. The other form is called an object-based normal map, and this is one of them. Now, as you can notice, there's a lot more colors involved, and all these represent pretty much the same thing. However, instead of adding to the smoothing of the model and adding to or editing the existing normal data, instead what this does is it completely overwrites the normals with its own, and this will allow for a very smooth model if baked correctly, exceptionally smooth, as in you can barely see the difference between it and the high poly model. It's exceedingly smooth, as I've said, as the main benefit is. However, it's not easily editable because everything's dependent on its axis in like the world and whatnot, and how you baked it, and it's simply not easy to edit with all these colors. Everything's dependent on what side it's on. Yeah, it's difficult. So that's why it's not used a lot in games. There's also quite a number of misconceptions about these normal maps. For example, that they can't be deformed, which is a load of hooey, because I believe one of the Battlefield games used it on their character models. So it can indeed be deformed. They can be rotated. I've heard some people say that these can't be rotated. However, they might be confusing it with world space normal maps. Now, world space normal maps came before object space, I believe. Now they're the exact same maps, however ObjectSpace has code in the engine or whatever that allows you to rotate the models and use them as physics models. So you can use them in real time without the light direction staying exactly the same. Now if I open up one of my previous models that has used ObjectSpace normals or normal maps, you will notice that you can indeed rotate these. And the light direction will change. However, one thing about them is that you also cannot mirror anything. All the UVs all have to be the exact. And I did that totally wrong here. All the UVs have to be also uniquely unwrapped. Nothing can be overlapping, nothing can be mirrored. So if we see here, nothing can be mirrored because the light direction will change. So that's another reason why it's not commonly used in games. With tangent space, however, you can indeed mirror it, and you can also overlap UVs because it is not dependent on unique stuff. Instead, it's just it can be toggled on and off, and it can be mirrored without any problems. Alright, so before we do any kind of baking whatsoever, we need to make sure that our model and UVs are both set up for the job. So when working with tangent space normal maps, you'll find that 90-degree angles do not play well with the normal map. This is due to the way that rays are cast, and I'll get into that later. But all you need to know is that 90-degree angles are not good with tangent space normal maps. So here's our model and UVs right here, and you can see that everything's stitched together on the UVs, and this is not good because, again, of the way the rays are cast, and I'll talk again about rays later. But what you need to know is that this will not work. Then you'll get errors and a warpy normal map, and it won't work for you. So the way we can fix this, one of the ways, is by breaking all these different smoothing groups on the UVs. So as you can notice, this is pretty much in a bunch of different smoothing groups. Each hard edge has a different smoothing group. So we can take all these different smoothing groups and break them away from each other on the UVs. And once we're done doing this, it'll be pretty much good to bake. However, if you can imagine having a large object and trying to do this for everything, for all the smoothing groups, it might take quite a bit of time, and you can imagine that it's quite difficult to texture this way. So there's a couple ways to work around that. The first way seems to be the way that most people seem to suggest. However, this is definitely not the most optimal way to do this. So this way, basically you chamfer everything, and the argument for this is that chamfering an edge will give you the same vert count as having smoothing groups, because once you put an object with smoothing groups in an engine, instead of like assigning the smoothing groups, it's going to manually break them off into another mesh. So what's going to happen is that for every smoothing group, you're going to have duplicate vertices around the edges where the smoothing groups have split off. So the argument is that it will create the same number of vertices as smoothing groups that way. However, this is a test that I did, is that this way, having everything split off, is at 48 verts at 28 triangles, while doing it with chamfering everything is 116 triangles and 60 verts. So this way isn't ideal because, first off, it's very difficult to UV. Secondly, because the vert and triangle count will both skyrocket, especially if you do this in a very large object. And thirdly, it's just plain messy if you keep doing it everywhere. So the compromise here is like this. Some edges here are chamfered, and these are areas that will specifically be easier to texture when they're stitched together. And some areas here are in a separate smoothing group. And so this here is 64 vertices and 60 triangles. So it's still quite high in vert count, but this will be far easier to UV, and it will also do the job quite nicely for your performance counting. It'll be a lot easier to texture, and it'll look pretty nice. So this is pretty much the optimal way. And if we take a look at the UVs as well, you'll see that we've got all the different smoothing groups split apart. So this object will bake just fine. And if we go to our baking test here, which will be the actual model that we're baking, you'll notice that it is indeed a mix of chamfered edges and flat hard edges. For example, this section here is split off, and this area here is more chamfered. So that being said, you'll be needing some practice in this area to get your clean bake in the future. So I suggest that you play around with all those methods and see which one works best for your model. So I guess it's time to bake some. So in order to bake this, we need, firstly, we need the low poly, which is in our scene. It's also UV'd, and everything's set up with smoothing groups the way it should be. Stuff with 90-degree angles have been split apart, and parts that would be easier to texture are also split. So next we need our high poly, which is already in the scene. And as you can see, these are both half of the actual model. Because what we can do with tangent space normal maps is we can take one side here and just mirror it over on the final, like we've done here. So as you can see, this whole portion is mirrored on the final, and we're only actually baking one half of the model. So we've got that. So now we need to set up some stuff before we bake it, and this is just to save some time later on. So what we're going to do is we're going to take the low poly here, and we're going to move all the different elements away from each other. This is a method called exploding a bake, or an exploded bake. So what we need to do is we need to make an edit poly modifier on top of this, and we need to drag all the floating parts away from each other, like this. Now we're doing this because when parts intersect and the cage is still trying to capture the different parts, stuff is going to be intersecting, and it's not going to look good. You're going to get a bunch of artifacts that should really not be there, and it'll take a lot more cleanup than is needed. So we've done this on an edit poly modifier because we can toggle it on and off, and that's done on purpose. I'll show you why in a little bit. So now we need to do the same thing basically for the high poly. So first off, we're going to select all of the high poly, and we're going to make a keyframe on frame 0. So we're just going to press this key button down here, and we made a key on frame 0. So next what we're going to do is we're going to unhide everything again, and we're going to start moving all the stuff related to each low poly element into each other here, as I'll demonstrate. However, first before we do that, we need to enable auto key. which is next to the key button. So now, as you can see, the viewport's red. Now we're going to move the slider here at the bottom to frame 1. And now we're going to start moving everything in place. As I said, each part related to each low poly element here needs to be moved into place. And by in place, I mean inside the corresponding low poly object. Now, this can get really tedious if you have a lot of floating geometry for each element. But in time and practice, you will get it. You'll get quite speedy at doing this. It's not as much of a hassle as it sounds. So we've got everything placed pretty much where we need it to be. And we need to now set up the cage. We can see here that now everything is moved where it needs to be. And we can toggle this all off. The exploded bake with the keyframes and with the edit poly modifier. So good stuff here. So now what we need to do is we need to add our cage and the projection modifier. So we're going to go and select our low poly. Now we're going to go to modifier list at the top, and we're going to select projection. So now you get all these blue edges, and if we go to cage mode on the drop down menu, we're going to see that now we have a bunch of blue vertices. So what we need to do first off to make our lives a lot easier is to go here on the side and say to cage, the cage rollout, and say shaded. Now this will make the cage shaded. So first off, before I do anything, what's a cage? Well, the cage controls how rays are cast onto your low poly. Basically, it controls how stuff bakes down onto the low poly. If you'd imagine a ray being cast, I believe, straight out from the low poly, basically a cage controls the distance of how far it casts. So how far it looks out into the distance to find something to catch on to. So what we need to do now is we need to make our cage encase all of the high poly pieces. So we have this element selected here. We're just going to use push here. So we just selected all the vertices, and we're just going to go push until everything is covered. So everything appears covered here. So we're going to move on to the next one. And we're just going to keep going on with this until we've got everything covered. Now we need to make sure that it does encase all of the high poly. So this explosion method here, this will give you the cleanest bake. The cleanest bake possible with as little errors as you can. So this here, this is pretty much all set except for this inside part. And as you can see, this lens is sticking out, this circle. So we need to go to go select all the different vertices. So I'm just kind of guessing where they're gonna be, but it may be helpful here to turn on wireframe mode and do something with that. So you might be able to see the verts better. However, I am blind or something and cannot see it. No offense. So we're going to now drag this out until it covers all the lens. Just like that. Now, one thing of note, you don't want your cage to be super huge. You want it to hug the high poly as tight as possible. So anyway, we're just going to keep doing this until we're done. Oops. So just drag parts out until until it's covering everything. The shaded mode is very helpful to fix these little errors like this, parts that are not fully being covered. So this bottom is not fully covered. So therefore we need to take all of these vertices and pull them out until it is covering everything. This here is also not being covered. There we go. So that's that. Now we need to do this main area here. And we also need to make it encase the floating geometry, which is this little bit on the top, this grippy part. And so I believe that's selected everything. And we're just going to use the push again, and we're just going to keep going up until everything is covered. And it's helpful to just have a quick run through, and you can much easier see what needs fixing. So I believe that's everything. So let me just give you a quick rundown of the other features here. You can easily select the vertices here, just entire elements, with shrink and grow. So you can grow the entire selection to just fit the entire element, and you can shrink it back down if you need. Other things are point to point, which will make your vertices basically display through other stuff, I believe. What point to point does is it traces a line from the actual vertice that it corresponds to, this cage corresponds to, from the low poly here. So basically the cage corresponds to the same low poly mesh. It's a copy of the low poly mesh, however it's modified to work this way. Here's some more errors where it needs to be pushed out some more. Okay. So anyway, I believe that's pretty much it. There's some more stuff in here. You won't really need to worry about them. Import and export is kind of interesting because it takes your cage and exports it as a different mesh here. This allows you to use your regular old polygon modeling tools to modify the cage. However, just make sure that your cage is still identical type topology to the original low poly, in that vertex order is even exactly the same. So therefore, you pretty much can only use like push modifier and bend modifier and stuff like that. And just don't make any extra changes to it. So anyway, we've got this. So now what we need to do is we need to add in the high poly stuff to this list here, to the reference geometry list. So we're just going to go to pick list. We're going to select everything. I say add. So that's pretty much that step. And as you can see, if we toggle on and off the edit poly modifier, the cage also goes with it. So this is great for baking an ambient occlusion later. So now we're going to do the long and tiresome part of actually baking this. And this will take a little bit of time, even on the best of computers. So remember that on your workflow. So in rendering here on the top, we're going to say render texture. And then we're going to set the output path first of all. It's already set here, but we can press the dot button on the side to make it correct. So we turn the padding here up to 3. The padding is basically just border pixels that are baked around each of the edges. to make sure that you've covered all the edges correctly. So next we need to enable projection mapping if it's not already enabled, and pick the projection modifier as we've already done. Next we need to go to options, and we need to make sure ray mischeck is checked for our test bake. You also see in here that there's some interesting options, such as normal map space, where you can change it to world space, which is also the same map which is used for object space. You can toggle this between world space / object space, screen, local XYZ, and tangent. You can also change the orientation of multiple channels, but you can edit that later in Photoshop if you need to. You can also enable super samplers, which we'll do for our final bake. So next we need to go and say we need to add an output map. So first off, we need to add a normals map. So we've clicked add and it said normals map. So next we're going to pick a relatively small size, 1024 by 1024. Background color is 128, 128, 255. That's just the standard neutral normal map color. And I believe that's pretty much it. Now we're just going to bake this out and have a look in our real-time shot. Just overwrite the files real quick. Now this won't take too long. It's also baking out ambient occlusion by accident. I've done multiple run-throughs of this tutorial to make sure that you get the best information possible. So it's important to make sure that you preview all your normal maps in a real-time situation using a viewport shader or a game engine or something of that nature, because I've touched upon this before, I believe, is that renderers use more complex mathematical equations to compute normal mapping, to view them. And real-time renderers, however, do not use those complex equations. They use more optimized ones that don't quite look as good, however, they save a lot of computing power in the process. So anyway, we've got our normal map rendered out. Even though this display does not show the normal map rendered out, it is indeed rendered out. So now we need to go to our shader here and import the normal map, which is, I believe, right here. So there we go. We've got a normal map. This is again just a test bake, so we've got these pixely issues here. There's also like the occasional bit of waviness here and there, and we'll fix that in Photoshop because it is easier. So otherwise, this is a relatively clean bake. The reason why we did a test bake is so that we could see it's a relatively clean bake before we go and make a full-sized bake that will take forever to render. So I believe this is okay. If you had any kind of issues with like major waviness, like this inside part here, you would end up moving the cage so it's tighter, or this waviness on the outside. If it's a waviness like this, you can just edit it in Photoshop. But otherwise, it just takes some cage adjusting to fix. So for speed, we're gonna delete the skylight here. All right. So I think we're ready to do our final bake. Everything's pretty much okay, I think. There's no gigantic glaring errors anywhere. So in order to do this, we're going to up the size to 2048, and then we're going to go to options up here again in projection mapping, and we're going to uncheck ray mischeck. Now, how you check for errors, by the way, in your bake, in your viewport rendering out window thingy, you're going to notice red lines when it bakes. Also on your output map, it will also be red spots. So you can check that for errors and missed rays. So in Global Super Sampler now in the same window, we're going to it's going to drop you back to the default rendering window. We're going to enable Global Super Sampler, and we're going to set it to max 2.5 star. We also need to disable object and image motion blur just for safety. So yeah, that's good now, and we're gonna let this render out, and I'm going to pause the video, and when it comes back, we will have our completed normal map. So we've rendered out our completed normal map, and as you can see here, it looks quite good. I'm pretty pleased with the result, and what we're going to end up doing is we're going to end up scaling this down in Photoshop at the end. This will allow us to fix even more errors, and it'll basically be a form of extra anti-aliasing. That's basically how it'll look at the end. So now we're going to bake down the AO, and so we're going to disable the edit poly modifier first off, and then we're going to move to keyframe 0. Okay, and so now we're going to add in a skylight with pure white. We're also going to add a white material, which we already have. The white material needs to be added to both the high poly and the low poly. So next we're going to select the low poly. We're going to go to render texture, and also make sure light tracer is on before I forget. That is pretty important. So anyway, so ray mist check should be off. Turn off Global Super Sampler because we don't need it. It's going to take longer if we do. So just for this tutorial or whatever, we're going to render the AO down at 1024. However, first off, we need to add a complete map. So delete normals map and add complete map. And now we're going to change the size to 1024. And I believe that's it. And now we can bake, and this is going to take quite a while. So while this is going, we're going to go and we're going to edit our normal map in Photoshop. So now we've opened up this. It's at 2048, as we can see here. And we can now fix some wavy errors and stuff. So first off, Smudge and Clone Stamp are going to be your friends here. So we're going to take out Smudge tool, and to fix some of these wavy edges, as you can see if we zoom up, these edges are rather wavy. So in order to fix this, we need to take the Smudge tool and just run it straight down. Let's just if you keep running it up and down, you're going to get it. But don't do that by accident, because I've done that way too many times. Yeah, you'll get it. I will too. So now we can do the same to this edge. Get that straight. Same with this one. Oops. Okay, now we need to clean up some more edges. Basically more of the same, because this is a very common error. So we're just going to continue with the cleanup. We're going to, over here also, we've got an error that we need to paint out. It's a lot easier and faster to paint out these errors than to go and try to fix your cage or model or whatever. So yeah. Just gonna smudge this up, and same here, and again on these edges. And basically we're just doing this so that the edges are straight again. When you have wavy edges, by the way, what'll happen is that it'll look fine from one angle, like this, for example, on this edge right here. But when you turn, it's going to look much, much worse. So instead, we're basically going to make it so that it looks fine from straight on, and it looks mostly fine from the rest of the angles. It'll look better, is what I'm saying. So we're just going to keep smudging these until we get everything, all the areas all painted out. We've also got some weird triangulation like stuff going on here, so I'm just going to give that a little smudge. Until that's about out. Alright, that's fine. So I believe that's most of the edges. Just browsing through here, seeing if everything's correct. Okay, I believe that's everything. We can give this a little smudge as well. Alright. If you want to be fancy, we can go along this edge too. But it's not necessary, because it looks mostly fine. So, okay, we've got our ambient occlusion now rendered out. So now let's pick this and import it onto the specular and diffuse slots. So that seems okay. So let's add it to the specular, and there we have it. That's our pretty much done normal mapped object with ambient occlusion now on. Before we do anything, before we apply this normal map, we're gonna add some painted on detail. So what I mean by that is we're going to use a height map to generate some extra detail on this. So I'm just gonna make a copy of this this image. And I'm going to make a height map by first off adding our detail. We're going to use, if we browse through the patterns, we're going to use this odd looking thing. I need to zoom in. Okay. So that'll look good enough. I also need to paint out on here, so that we need to mask off this bumped out grippy bit, is what I'm saying. It might be helpful to put this on a lower opacity so I can see what I'm doing. So I'm just gonna go with a black brush and paint out roughly what we need off, and the rest I'm thinking we're just gonna go along with a fill here. Oops. There we go. It's good enough. So now we need underneath this is we need a 50% gray, and we're also gonna just rasterize this. And we're going to adjust colors and the brightness, so that's a bit more neutral. Okay, so we've got that. I'm just going to flatten the image. We're going to use the NVIDIA normal map filter, and I have it set to filter type 4 sample, scale 5, alternate conversions, max RGB. Everything else is the same, just defaults. Alright, so that's rendered out, or that's filtered. So now I'm just gonna paste it as a new layer on top of our normal map, our baked normal map. And if we set this to overlay, you might notice how everything's gotten a lot bluer, and there's a definite change here. So to fix that, we're gonna go to image, and we're going to say adjustments, and we're going to say levels. So now we're going to channel blue, and output levels should be 0 and 128. So now nothing's changed colors, and now we can save this out as a TGA and as our new TGA. So now here in our normal map, I'm going to select, or in our real-time renderer, we're going to select the new normal map, and we've got added on details that we've painted on with Photoshop. So for a better smoothness also, I promised that I would scale down this map, the normal map, for better edges. Basically, by doing this, it'll slightly blur the map, and it will give it a form of anti-aliasing. So I'm going to set the width and height to 1024, and resample image should be set to bicubic, not bicubic sharper. So we can scale this down and save this out. Now you might also want to choose to do details after you scale it down, but I did not. So yeah, the edges are softer now. Also, you may notice that, for example, this edge here is a lot more round now. So yeah, we fixed a lot of errors. And you may need to smooth out some of these edges on the ambient occlusion as well. But I believe that's pretty much it. So, hope you liked it, and thanks for watching.